Hello and welcome. This is going to be our lecture video for May 4th. I'm going to be talking about more than and less than probabilities. So our goal today is to understand how to calculate more than and less than probabilities, specifically for events that require permutations. Why we're doing this, to be able to find probabilities when multiple results will help us meet our goal. So this is kind of often the way probabilities work out, where we're not looking for a specific result. We want to get like a range of results. As long as we beat a certain number or have at least a certain number of events happen, then we have a success. So this is maybe an even more applicable way to look at probability. All right, so we're going to look at this one and try to really intuit why the formula makes sense with this. So we've got a technician launching fireworks near the end of a show. Of the remaining 10 fireworks, 5 are blue and 5 are red. If she launches 6 of them in a random order, what's the probability that at most 3 of them are blue? So, important things here. There's 10 fireworks. 5 blue, 5 red. She's going to launch 6 of them. We want to know the probability that at most 3 of them are the blue ones. Okay, so we need to be very organized with this information. So maybe it'd be useful to just draw out 5 red fireworks and 5 blue fireworks, just to help us think about what's going on here. So these little boxes will represent fireworks. And we're going to launch 6. So maybe we'll bracket 6 of them. Maybe we grab these first 6. All right. Now we want the probability that at most 3 are blue. So let's split up this probability. This is kind of hard to handle because with 5 blue rockets, we could shoot off 1 blue, no blues, 2 blues, 3 blues, 4 blues, 5 blues. So we kind of have to solve these different probabilities differently. So in how many different probabilities are at most 3 blue? So this would be the probability that 0 are blue plus the probability that 1 is blue plus the probability that 2 are blue plus the probability that 3 are blue. Okay, so that's 4 different probabilities to calculate. But this altogether should get us the probability that at most 3 are blue. Because if you have 0 blue, then we have not gone over 3. And 3 is okay, at most 3. So 3 is allowed, but we can't go past that. But there's a slightly quicker way to do this. Because we can only go up to 5, we could calculate the probability that 4 are blue and the probability that 5 are blue, and that's just 2 probabilities. And we can say that all of these together have to equal 1, right? Because something has to happen. We can get between 0 and 5 blue. So if all of this together adds up to 1, then if I just do 1 minus these, that should be the same as this. These are equivalent. All right, so you can either calculate these 4 probabilities or just calculate these 2 probabilities and subtract from 1. And this is going to be a little bit faster. Okay, so we got to figure out these probabilities individually. So what's the probability that 4 are blue? Exactly 4 need to be blue. So here's how I like to do this. I like to just figure out what's the probability of one scenario and then go from there. So this is our scenario. We're going to say this scenario is that the blue one comes right in the middle. So we're going to shoot off a red first. So what's the chance of shooting off a red? Well, it's a 5 out of 10. And then we're going to shoot off another red. That's 4 out of 10. Then we're going to shoot off another red. Well, actually, it's not 4 out of 10. It's 4 out of 9 because one of the rockets is gone. Then I'm going to shoot off another red, so 3 out of 8. But at this point, I'm going to shoot off that blue. And there are 5. Oh, wait. I want 4 of them to be blue. So I was doing just 1 for some reason. Okay, so we'll say the first 2 are red, then the rest are blue. So now we got a 5 out of 8 for the blue, then a 4 out of 7 for the next blue, then a 3 out of 6 for the next blue, then a 2 out of 5 for the next blue. So this would be better if I label this. So we went red, red, and then blues all the way out. Blue, 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 blue. All right. So this here will, if I multiply this out, this will give us the exact probability that we shoot off 2 reds and then 4 blues. But this could have happened in a different order. We could have shot off a red first, which there's a 5 out of 10, then a blue, which there's still 5 out of 9 remaining there, and then another red, so there's 4 reds left out of 8 red rockets, then a blue, so 4 out of 7, and then 2 more blues, so there's 3 blues left, so 3 out of 6 times 2 out of 5 blues left. So this one went red, blue, red, blue, blue, blue. And if you compare these, you'll see we've actually got something in common. If I turn them into one big fraction, these are actually identical. It's just that the 5s and the 4s got switched around. All right, but the numbers are still the same because when I shoot off that second red, there will always be 4 reds remaining. It could happen at the end, it could happen towards the beginning. There will always be 4 at that point. Same with the blues. There'll be 5, then 4, then 3, then 2 left. So this probability here gives us one scenario, but all of the scenarios are going to have equal probability, going 2 reds first, or red, blue, blue, blue. So we just have to figure out how many different ways can we shoot off 6 rockets and have 2 of them be red. Well, that's 6 choose 2. This is the number of ways to choose 2, so choose 2 to be red. And what is 6 choose 2? I'm just going to do that on my calculator. 6 choose 2 is 15. So there's 15 different ways to put these reds in here. You know, I can go red, blue, blue, red, blue, blue. Count those all up, there's 15. So I'm going to take this probability and multiply by 15, and that's going to get me the probability that 4 are blue. So let's actually multiply this out, and multiply this one. And I like to just multiply all the numbers that are on the top. So 5 times 5 times 4 times 4 times 3 times 2. And then do divided by, in parentheses, all the numbers on the bottom. 10 times 9 times 8 times 7 times 6 times 5. And I get that this here is equal to 0.01587. But then if I do 15 times that probability, we'll go ahead and multiply by 100% now, just so we can understand it better. So times 15 times 100, there's a 23.8% chance that of those 6, we're going to shoot off 2 red and 4 blue. All right, now we got to do the probability that 5 are blue. And that also means 1 is red. That because you have to shoot off 6. If 5 are blue, then 1 must be red. And we can't do the probability that 6 are blue because that's impossible. We only have 5 blue rockets. So let's figure out one probability. So it would be 5 times 4 times 3 times 2 times 1 times 5 for the blues. And then the red. Whenever we shoot off that red rocket, there will be 5 of them remaining. And this will be divided by 10 times 9 times 8 times 7 times 6 times 5 for how many total rockets are remaining for each firework we shoot off. All right, now we have to multiply this by 6 choose 1. 6 choose 1 because there's only one red rocket to be placed amongst these 5 blue ones. And 6 choose 1, we should know that that is equal to 6. So 5 times 4 times 3 times 2 times 1 times 5. Divide that by, in parentheses, 10 times 9 times 8 times 7 times 6 times 5 times 100%. There's a very small chance that this exact scenario is going to happen. Did I multiply by 6 yet? I did not. I need to multiply by 6. It's only a 2.38% chance that we shoot off all the blues. Add these together and we'll get, I'm going to do it on my calculator, so plus 23.8. We get the 26.1% chance. So this is the chance that we fail, 26.1% chance that we fail. So we subtract that from 100%. So this is them together. And we get 100 minus second answer, 73.81. 73.81% chance of success. Okay, one more problem. That's all we got time for in this one. The gardener has 13 identical looking tulip bulbs, of which 5 will produce yellow tulips, 8 will become pink. So let's just draw that out. So I need 5 yellow, 2, 3, 4, 5, 8 pink, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to plant 7 of them. So I'll plant these 5 of these 2. So we're going to plant 7. But we don't know which 7 because it's at random. What's the probability that at most 3 of them are yellow? So we can do 1 is 0 yellow, 1 yellow, 2 yellow, 3 yellow. That's 4 different probabilities. Or we could do the probability that 4 yellow, 5 are yellow, and subtract from 1. I think that sounds better. So let's set up our equation. We're going to do 1 minus the probability that 5 are yellow, or we'll start with 4 yellow, and then 5 are yellow. And then we can stop because we only have 5 yellow possible. So 4 yellow, and in that scenario, 3 would be pink. We'll do that. 4 yellow, 3 pink, minus the probability of 5 yellow, 2 pink. All right, let's try to do this with permutations. So probability that 4 yellow, 3 are pink. So we can do 5 pick 4 for the number of ways to pick those 4 yellows, times 8 pick 3 for the pinks, divided by, together, 5 plus 8 is 13, so 13 pick 7. So that's for your yellow, that's for your pink, and that's for your total. So 1 minus that, minus, all right, so how can I pick 5 yellow from 5? There's only one way to do that, but we could do a 5 pick 5 just to keep it consistent. Let me think for a second. Should this be times? Yes, this should be times. So times 8 pick 2 all over 13 pick 7. I'm going to try plugging this all into my calculator, just having the calculator do the work. Well, I'll do it in 2 pieces. So I'll do 5 pick 4 times 8 pick 3 divided by 13 pick 7. This was a 0.00 Oh yeah, I'm missing. So that would be one arrangement. I'm missing all of the other arrangements where I do a I'm planting 7, so a 7, choose 4, for which 4 are going to be the yellows. And this one needs a 7, choose 5, for which ones are going to be the yellows. So we use the number of ways. All right, I thought that probably looked a little bit low, so we're going to multiply this by 7, choose 4, and I get 0.16317. We'll do this one. So 5 pick 5, which is just, well, it's 120. Oh yeah, because we're going to get rid of those different rearrangements with the 13 pick 7. I think I said it was equal to 1 earlier. That would be 5 choose 5. But 120, that's okay. Times 8 pick 2 times 7 choose 5 divided by 13 pick 7. And this one is a very small number, but this, it makes sense that these extreme cases are very small numbers because it's very rare to just plant all 5 of the yellows. Normally one of them gets left out. So 0, 1, 6, 3, and then we'll complete the subtraction there. So 1 minus that number minus 0.16317. I get 0.82051. I'm going to multiply that by 100%. Get there's an 82% chance that at most 3 of them will be yellow. Okay, these are tough. You saw I even made a mistake. I forgot my combination there. I think this is the easier way to kind of think through it, where you actually set up the fraction and then you do the combination. Whichever way works best for you. And I'll probably make these multiple choice so that as long as you get an answer in the list, you know you've done it correct, because these are hard to double check. All right, have a great rest of your day. That's that for this video.